Francis. And welcome everybody to the opening plenary with Dr. Amanda Lynch. I have to congratulate Francis and his colleagues on the Scientific Program Committee for really an excellent opening plenary speaker and topic that really aligns well with the Congress theme, Science Serving Society. Amanda is the Lindeman Distinguished Professor in Earth and Atmospheric and Planetary Science at Brown. She's the founding director for the Institute for Environment and Society. So the word society is certainly important in her role. She's a fellow of a number of academies and societies in the USA, the AMS, Australia, Norway, the World Academy of Art and Science, and she's the chair of the World Meteorological Organization Research Board. And I think that she may be the first chair. I know that I know a number of colleagues in the research program there, and the reorganization I think has been relatively recent. So congratulations on being perhaps the first WMO research chair. One thing I realized is Amanda and I and a few others have one small thing in common, and that's we Googled CST, the Central Standard Time, to try to figure out exactly what time it is. I'm in Halifax, and initially it said 2 hours, and so I messed that up, and certainly Francis and others fixed me up, and Amanda and I and Francis and actually several of the panels I'm involved in had the same experience of dealing with Central Standard Time. I sent a note to the American Met Society colleagues yesterday, and they were confused by CST. So Amanda and Francis and I have had a few laughs associated with Central Standard Time. So I'm really looking forward to Amanda's talk, sea ice retreat and navigation, and the implications from climate scenarios for Arctic geopolitics. Amanda's going to talk for about 35 minutes, and so we're going to have lots of time for questions and answers. So feel free to use the Q&A box on your screen to address some questions and answers to Amanda, and I'll turn it over to you, Amanda.
Thanks very much, Jim, for that kind introduction. I'm actually technically not the first chair of the research board after the World Meteorological Organization underwent a major reform, as you said, and for a time that chair was held by the vice president of the WMO, Celeste Saulo, who's head of the Argentinian Meteorological Service. But I was indeed the first elected chair for my sins. So I am now going to attempt to share my screen, and hopefully the technology will be in our favor. So I'm hoping everyone can see this. So yeah, today I would like to talk about one way that we can use our climate scenarios to inform the evolving geopolitical situation in the Arctic, even in the context of very high uncertainty in our models, in the trajectory that we're on, and indeed many other uncertainties. And so many of us as natural scientists struggle at times to provide policy relevant information that acknowledges the uncertainties. And so this work that I've been conducting with my collaborators, Charles Snorkey, who is at the Centre for Oceans Law at Maine School of Law, Michael Goldstein, the Department of Finance at Babson College, and my doughty postdoctoral fellow, Zhueke Li, at Brown University. we've been working on developing approaches that incorporate uncertainty into policy relevant insights, and it's that work that I'd like to share with you today. So the focus of the work is around Arctic ice retreat, which is certainly dramatic and not under any kind of contention. And so I'm drawing these figures from the latest IPCC report as being our kind of definitive understanding of where we're at now. And so what we can see if we look at Arctic ice retreat over the satellite era, we get very strong winter ice loss in the Barents Sea, and that certainly has implications for things like exploitation of hydrocarbons, which is something that I've been looking at. But what I'm particularly interested in and will focus on today is sea ice losses in the summer, which, as you can see and as we well understand, are occurring primarily in the eastern Arctic, and we have something of ice refugia in the Canadian Arctic. And it is this particular characteristic of the ice loss that has implications for evolving access and control in the Arctic. We understand, based on rigorous attribution studies that have fed into the sixth assessment, that about half of this, well, at least half of this satellite observed summer ice loss can be attributed to anthropogenic climate change. We have significant intraannual variability, of course, and we also have low frequency variability that we're dealing with as well. But this is certainly, a very robust signal. And then, despite the fact that most of the models in the Couple Model Into Comparison project, round 6, fail to simulate the sensitivity of ice specifically to greenhouse gas concentrations, they are improved over the CMIP5 round. And so what you can see on the right are the number of models that are reporting above 15% sea ice concentration at the end of winter in March and at the end of summer in September at mid-century. And what we can see is very much this same signal of ice loss that is continuing the trend that we're seeing right now, which is enhanced retreat from the Russian Arctic and the maintenance of some summer ice refugia on the Canadian and Greenland side. And so both the actual ice retreat and these projections of change, which are robust and well attributed, are creating expectations for both economic development and strategic exploitation of the Arctic. There have been articles talking particularly about Arctic shipping, for example, that were published, as long as 8 or 9 years ago, projecting this idea that the Arctic was going to be accessible because of ice retreat, and that would enable through shipping. But in fact, there's a lot more activity in the Arctic than just the possibility of container ships passing through. We have the 5 Arctic coastal states that are shown here: Russia, Norway, Denmark, under whose jurisdiction Greenland falls, Canada, and the US. And all of these Arctic littoral states are seeking a variety of different opportunities in this Arctic retreat, in this sea ice retreat, which includes not just accessibility for shipping, but also exploitation of hydrocarbons and other mining opportunities, and certainly strategic deployments in the Arctic, which are occurring around the entire Arctic Ocean. And so this set of expectations that are developing amongst those 5 Arctic littoral states, that is the coastal states around the Arctic, but also the other 3 Arctic states that do not have coastline in the Arctic, which are Sweden, Finland and Iceland. And then we also have the non-Arctic observer states such as, China, Singapore and the like. That these states are expressing this sense of the race to the north through exploration of navigation for through shipping. And this has real attractions for not just for the Arctic states and Arctic observing nations, but also for global shipping companies, because the Arctic route is about 40% shorter than the Suez Canal. As we've seen, there was the Ever Given blockage that last year was estimated by Lloyd's List to have cost around $400 million US per hour for that blockage and blocked the Suez for several weeks. Shipping in the Arctic is becoming regularized through the adoption of the Polar Code, which, along with requirements for Polar Code vessels, including ice strengthening, also simplifies the insurance process for those vessels. There's been a lot of discussion about the idea that the Arctic isn't really that much shorter than the Suez because shipping speeds are slower. But in fact, what we've been finding, particularly in the context of supply chain problems, that slow shipping speeds have been adopted worldwide. And another reason for those slow shipping speeds is the adoption of guidelines for reducing greenhouse gas emissions by these container ships, and they can reduce their emissions overall by adopting slower speeds. And so you have a confluence of factors that are affecting shipping speeds, which means that the Arctic route is now more competitive on a speed basis as well as on a distance basis. And then, of course, because it's shorter, there are lower emissions associated with the Arctic route. There are concerns about the impact of ships impinging on the sea ice, but the studies that have been done to date, some by my group and by others, indicate that this is not a large signal compared to the overall load of aerosols, black carbon, but also greenhouse gases that come from shipping worldwide, and indeed industry in Russia and China. That is a much bigger signal than from these ships. But importantly, for this idea of the race to the north, is that navigational certainty is required for every activity that seeks to exploit the retreating sea ice. So this includes infrastructure development, hydrocarbon exploitation, seabed mining, strategic deployments, which I'll talk a little bit more about, and also fisheries range migration. We're seeing species ranges shift under climate change, and so the fishing fleets are having to shift with those fisheries. And then, of course, you have tourism is another very large player in this Arctic navigation space. So, there are debates as to whether this is an appropriate use of the Arctic in terms of its environmental implications, but there certainly seem to be net benefits in terms of global greenhouse gas emissions, which means that it's important that we look at this. Also, this stuff is going to happen anyway, and so we do need to understand it from that standpoint. So what we've been thinking about in my group is how we look at that very complex context and think about what kind of guidance can we get from climate scenarios. So to look at this, we selected 16 of the CMIP6 models. These were models that were identified under the CISMIP component of the model intercomparison projects to perform well in the satellite era of observed sea ice retreat. So their sensitivity is reasonable. And so what you can see here are the scenarios from these realizations, and we took a single realization from each model and projected those out to 2065, this being the block of time that's important for infrastructure investments. We have a pretty clear sense, if we don't do something serious about climate change, where we're going to be in 2100. The question is not so much where we end up, but the path we take to get there, and then how that might shift as we develop mitigation efforts. And so it's that kind of uncertain interim infrastructure investment time that we're seeking to understand. We selected the quite aggressive SSP scenario, climate change scenario 585, which suggests more or less a continuation of business as usual. And we calculated for this the navigable routes for open water vessels. We can also calculate this for different levels of polar code vessels, but we wanted to look at open water vessels in particular, as that kind of indicates a parity with a Suez type scenario. And we chose to focus particularly in thinking about what from this kind of cloud of realizations might be useful. We chose to look at the Northern Sea route, and I'm hoping you can see my arrow here. The Northern Sea route is actually formally designated as that part of this Eastern Arctic route that traverses through Russian territorial waters and the Russian exclusive economic zone. The route as a whole, which goes from essentially from Rotterdam out through the Bering Strait and vice versa, has come to be called the Northeast Passage, and the Northern Sea route has been claimed as being the Russian part of that. But I might go back and forth between those terminologies. So looking at that cloud of possible sea ice futures from these 16 models, we calculated the length of the viable shipping season, and that's what's shown here on the right, from 2015 out to 2065, the number of days, contiguous days, that you can have an open water vessel passing through the Arctic safely at an acceptable level of risk according to Polar Code and the International Maritime Organization. And so what you can see is that, again, the ensemble mean is pretty clear. We know that the length of shipping season is increasing as the ice retreats. But what we can see here is that the interannual variability in the projected season length is very large. Some years there is no season at all. Other years there is upward of 150 days. But also, and this is the sticker for policy advice, uncertainty among the model realizations is also large. And so what that means, and these are the lines at the bottom, these are the indicating the year at which each model says the first 90-day shipping season can be realized. And so you can see that there are some models are saying we can do that already, and there are some models who are saying we can't do that past mid-century. And so this kind of set of projections is very difficult to act on in terms of making a decision. And so what we did was to use an option pricing model from the world of finance. It's called the Black-Scholes pricing model. It allows you to calculate the cost of various put options and the risk associated with them. And we evaluated the expected additional cost incurred if you have to use a 40% longer route in the Suez Canal if the Northern Sea route can't provide a sufficient length of the shipping season for the global market. And so that's what this curve shows you. So the black line here tells us the additional cost if we had perfect knowledge of having to go through the Suez Canal. So this indicates that additional 40% increase in distance, and the more days we need of it, the more it's going to cost. And that's the black line. But of course, operators do not have perfect knowledge. And so the common thing to do, and the thing we often talk about doing, is using our ensemble means, and that's our kind of best understanding of what our models give us. And that's this dashed green line, dark green line, is the ensemble mean cost curve that operators, when operators assume a risk based on the information they have, this is what it's going to cost them. Because we don't have perfect information, you can see that there is an additional cost even when we're getting the needed season length. And this calculation is robust to however many days you need. So it's just the ratio of supplied to needed season length. However, if we calculate that cost curve for every individual model, you can see we have a cloud of cost curves, all of which fall above the ensemble mean cost curve by a substantial amount. And the mean cost curve of the ensemble is much larger cost than the cost curve of the ensemble mean. And so I'll say that again, the ensemble mean cost curve is higher than the cost curve of the ensemble mean. And this is something I think we've seen before in other types of highly variable climate records, but this quantifies it in terms of dollars. So what we found in interrogating these cost curves is that the cost difference between the realized and the projected assessment is large. As you can see, it reaches its maximum at the needed season length. And so as we're coming up to that period where we're getting the number of shipping days we need, that's where the cost difference between the realized and the projected assessment is large. But more importantly, as I said, when we interrogate that, the interannual variability, which is expressed in this blue curve, weighs more than the model uncertainty in our cost estimates. So interannual variability from the standpoint of an operator trying to decide whether to send his ship or not costs more than being uncertain about which model is the best. And so this context where there's a lot of uncertainty, but there's also a lot of appetite for using this route, and indeed the use of the route has increased in recent years, means that demands for access are met with claims for control. And this is where we get into the legal aspect. So, what we're seeing is that as sea ice retreats and as sea level rises, we're starting to call into question key provisions of the international law of the sea that governs these changes. And so a very quick primer on the UN Convention of the Law of the Sea, which took a decade to negotiate. The law of the sea establishes maritime zones. It establishes those zones from a territorial sea baseline, and that baseline is likely to move as sea level rises. So there is uncertainty looming associated with the baseline. And so what that means is the distance to the 12-mile territorial sea zone and the 200-mile exclusive economic zone is going to be shifting. And it is these zones that we need to think about when we're thinking about access for shipping. So sovereignty extends in the territorial sea to the airspace, the water column, the seabed, and the sea soil, the subsoil. The exclusive economic zone is associated with exploiting and managing living and non-living resources in the water column and the continental shelf. And then the continental shelf can extend further than that. The key provision for our purposes is the UN Convention on the Law of the Sea, Article 234, which pertains to ice. It was introduced jointly by Canada and Russia in the negotiations. And the text of this article states that coastal states have the right to adopt and enforce laws and regulation, particularly around management of marine pollution. So it has an environmental target where the presence of ice for most of the year creates obstructions or exceptional hazards to navigation. And so the key phrase there, which is maddeningly imprecise from the standpoint of the science, is the presence of ice for most of the year. That is as detailed as it gets. And so what we found in the past decade or so is that Article 234, which was intended to be a law that allows coastal state authorities to protect the polar marine environment, what has occurred through the development of the Northern Sea route, particularly, as I say, in the last decade, is that they're using Article 234 to extend enforcement jurisdiction to the entire Northern Sea route, defining that route as being entirely in Russian territorial waters, and providing authority for levying tariffs and requirements on shipping, also on innocent passage and navigation of government vessels, such as those associated with the armed forces, which are not intended to be covered by this law. And so they are really pushing the limit of what that article is intended to be used for. And so we decided to look at that. We extended our perspective to look at all of the different scenarios so that we could start to engage the spread of those scenarios. So this is now the season length for all of those scenarios, from the most aggressively cutting of emissions, SSP 126, up to the kind of business as usual. And what we wanted to understand was how many routes that we identified could be realized outside of the Russian-administered Northern Sea route. And this cloud shows all of the routes that our algorithm identifies. This is towards the end of the century. You can see, as well as the Northern Sea route, which Russia identifies as being in their territorial waters. Also the standard Central Arctic route. We can see another route emerging that goes across the top of Greenland, and then of course the Northwest Passage starting to emerge as well. And so when we look at the navigation probability for open water vessels, that is vessels not requiring icebreakers, because the Russians also have most of the icebreakers, what we can see is that the probability of being able to navigate outside of Russian territorial waters increases dramatically, faster for the more aggressive emission scenarios, business as usual. If we are aggressive in our reduction in emissions, that increase in navigational probability starts to level off by the end of the second half of this century. But what you can see is that interannual variability, which is indicated by those dots, remains a very large factor in thinking about the potential for navigational probabilities outside of Russian waters as we get towards the second half of the century. And so what we find then is we have a situation where we can see very much where things are headed, that the potential for shipping companies and other actors in the Arctic to free themselves from the some would say spurious Russian jurisdictional claims over the Northern Sea route, that probability is increasing, and with it, a sense that there is going to be exploitation. Even if this isn't realised in the near term, we can see that global seaborne trade is up. It's certainly flattened in the last year or so, but there is every expectation that it will increase again. Russia is actively expanding their Arctic infrastructure footprint in the region, but perhaps more importantly, emerging demands of non-polar states such as China, India, Korea, and Singapore are starting to be felt in many of these test navigations. And these are not always guided by a sense of environmental custodianship. And so what this is telling us is that Article 236 is not giving us the kinds of protections that might have been expected when it was introduced, and that in fact is being invoked for purposes for which it was not intended. And so as this context evolves, there will be many events that affect the object and the purpose of the UN Convention of the Law of the Sea. Most critically at the moment, Russian sanctions, which we've also incorporated into our calculations, but those are kind of hot off the press, are going to affect how this article is interpreted and how it goes forward. It's certainly true that new sea routes will be specified. They're already emerging. These will drive the development of new regulations that pertain outside of the Russian-administered Northern Sea route. But what this tells us is that this provides a window of opportunity for recalibrating the international law of the sea, and for thinking about what that article is really intended to achieve for the maintenance of the Arctic environment and the ongoing peaceful use of the Arctic. And so with that, I will stop for questions.
Well, thank you very much, Amanda. Feel free to fill up the Q&A area. And I have one question that was asked in the chat. Let's see, it was Alex. And he was asking Amanda about the difference between ensemble mean cost curve or the cost curve mean of the ensemble.
So yeah, so the idea is that you can calculate a cost curve of the operator costs based on their expectations for being able to access the sewers, based on any trajectory of season length. And so if you take the ensemble mean of the season lengths, the interannual variability is smoothed out. As we know, whenever we do these ensemble means, we lose a lot of that because of the offsets between those different things. And so the costs associated with interannual variability gets washed out when we use the ensemble mean to calculate the cost curve. When we calculate the cost curve of every ensemble member, then that preserves the interannual variability, and so you have much higher costs, and then we take the mean of all of those costs, and that gives us that cost curve. And so what we lose going between the two is interannual variability.
Thank you. And we've got a couple of questions related to bias correction. Jeremy really loved the interdisciplinary nature of the talk and suggests bias correction and or downscaling are often used to adjust global climate models and the derived climate metrics prior to the use and consequential adaptation planning. Are there currently feasible avenues for effective bias correction of sea ice production from the climate models? And then related to that, another attendee asked, what method was used for bias correction of the climate simulations?
So we didn't do bias correction of the simulations, and I would defer to the sea ice modelers who are doing that. What we were trying to do was to model the behaviour of your average kind of maritime shipping operator or scenario developer associated with strategic planning or infrastructure development or hydrocarbon exploitation. What happens in that world is they take the CMIP6 scenarios and they use them to create their forward plans, and they use that to develop their risk models, which is what they're really trying to do. So they're not looking for, the projection that rules them all. What they're actually looking for is an assessment of risk. And so what we were trying to do was to interrogate how you could create that assessment of risk in a more accurate way, and then subsequently look at the implications of that for the geopolitics associated with new negotiations on the law of the sea and also for sanctions.
Thank you. Now there are a couple of questions that are related on feedbacks. Ruping asks, what are the major feedbacks to the atmosphere of Arctic sea ice loss? And then Olivier asks, can Dr. Lynch comment on the possibility of a rebound effect on the shipping emissions from using the Arctic and greenhouse gas emission increase? Or it was mentioned that greenhouse gas emissions would lower because the route is lower, but don't we expect that this would be an opportunity just to ship more stuff? And so what are these kind of feedbacks you're considering?
Yeah, no, that's certainly true. It is it does the moral hazards associated with looking at these kinds of things, it's very similar to thinking about the moral hazards associated with, for example, geoengineering. That if you work out the kind of the parameter space of these solutions, you start to make them seem, like that's a really good idea and we should do more of it. And we see that with geoengineering, and I think that there is a risk there that shipping could increase if we just add another route. And so, there's certainly no doubt that that's a risk. In terms of the feedback, so one of the things we were trying to do was to look at, what are the, and this was a whole other set of work that I didn't talk about, but what are the impacts of moving all of the ships from the Suez to the Arctic in terms of the impacts on greenhouse gas emissions, on aerosols in general, and on black carbon specifically. And what we found was that from a climate standpoint, globally, there's a net benefit. If we don't increase the total amount of shipping, there is a net benefit, even if you ship slower to go through the Arctic. However, the devil's in the detail. So what we did find is that there are regional differences in that response. And so there are regions, particularly on the Canadian side, where it's actually there is an area of detriment. There's an area where it causes problems. And so that's where regional models in particular, and starting to get very specific about regional sea ice modelling and high resolution sea ice modelling, will hopefully get us to that answer. And that appeared to be connected through actually a circulation shift that caused a redistribution of ice. It was kind of interesting.
Thank you. And actually, kind of related to that, Peter Taylor asked the question, is there a simple explanation of why the ice persists longer on the Canadian side of the Arctic compared to the Russian side?
My understanding, I mean, I read the literature like everyone. I'm not doing scenarios myself anymore these days, but it's associated largely with the prevailing kind of redistribution of ice. And so what we're getting is the prevailing winds, we're getting the ice being pushed off the Russian coast and being pushed over to the western side. And so you tend to always have thicker ice on the western side. It also tends to be somewhat colder on that side. And so those two things together means that the ice pack just persists longer. You've got more thicker ice, and so it can manage to survive the summer melt. Because this retreat, it's all about how much ice survives the summer melt.
Thank you. And you mentioned black carbon, and David asked the question, will the increased shipping and the increased particulate deposition associated with these emissions result in enhanced melting? And I think you kind of alluded to.
It's tiny. It's tiny. If you compare it, for example, to the output of soot from Russian and Chinese industry, and that getting blown off coast, that's a much bigger signal than these ships.
Exactly. And George asked the question about the model performance up to now, like the line casting. How well are the models performing, looking at the existing loss of sea ice?
So we tried to choose the 16 models that the Sea Ice MIP indicated were doing the best job in the satellite era in terms of that retreat, and and they're doing reasonably well. I wouldn't say that we're there yet, but certainly everything that I've read about the performance seems to be saying that the remaining issue, which is in the hands of the people who now develop models, not me anymore, is the interaction between ice and atmosphere. That the ice by itself seems to do a reasonably good job. The atmosphere by itself, if driven by the correct ice, does a reasonably good job, but we're failing in the interaction. And I also know that there's some really exciting work being done on modelling of individual flows and really modelling, changing the paradigm of sea ice models, which is kind of exciting.
And actually, there's a question kind of related to that wondering why there's so much spread on the 2015 model predictions. So we took those. What we did was we took the scenarios that were actually started back at the turn of the century. So because we were trying what we thought we were going to do, and we ended up not doing it, but we thought we might be able to do some kind of useful validation in that period between 2015 and now. And so we used scenarios as opposed to kind of the constrained, the observation constrained simulations. But what we found was that it was actually not possible to do validation on the navigation season because when we interviewed operators about why they were sending ships at different times, there were so many other reasons that had nothing to do with the ice that we couldn't do that validation. And then, of course, for the Russians, they will run ships 365 days of the year because they have the icebreakers and they're just running ships all the time. So their season is all year. And so we found we couldn't do the validation, but since we had the data, we used all of it. Thanks. Good question. About 10 years ago, when I was working, I hosted an Arctic High Coast meeting here in Halifax. And really the objective was to get the Russians to share their freshwater flow to sea data, because there was a gap in the amount of data that was being shared with respect to the freshwater input to the Arctic Ocean. And after the meeting, I had a lobster dinner and some local beer, wine, and vodka, and we actually ended up getting an agreement. But given the strategic discussion, sovereignty discussion, and certain conflict that's going on now, do you sense that there'll be some challenges in data sharing and open data, model sharing and the like associated with the strategic advantage of some of this, of the Arctic, for example?
Oh, yeah, I do think so. I mean, it's happening even now. We can track a lot of the ships using the AIS system, which allows us to do tracking. But people will have seen recently that there are Russian super yachts that are turning off their AIS, and indeed. There's activity in the Arctic by the Russians where they're turning off their AIS, and we know that because we can see the ships on satellite, and they're not posting their signals. So that's certainly happening already, and also because they're requiring, the regulations that they're applying to any vessel, including, for example, United States warships, which is not intended and not provided for under that article, or indeed under the Convention of the Law of the Sea. So, there are already violations taking place. And of course, the Russians see Arctic ice retreat as a net benefit for them. And so, so they have competing incentives as well.
Exactly. Michael asked a question about and I'm sure there's some seasonal forecasters in the audience. So the value of seasonal ice forecasting and the investment we should be making, given the importance of interannual variability, do you have any thoughts on how much effort we should be putting in seasonal sea ice forecasting, which is a challenge, of course?
Yeah, no, I think that it would be tremendously useful. I mean, the decision to send a ship across the Arctic, it takes, just under 2 weeks, so I mean, between 9 and 12 days to go through from the Bering Strait out to the Barents Sea, or vice versa. So those kinds of forecasts would be very useful. But then the idea of having seasonal forecasts that would allow operators to make a decision about their deployment for a season, I think, it would be very, very useful. I know the Norwegians are working on this, and it's something that would be very useful. The other issue is satellite coverage over the Arctic, GPS coverage, and emergency management. All of those things are very important, because if your ship breaks down in the middle of the Arctic Ocean and you're in international waters, whose problem is that?
Yeah, and that's really interesting, because I guess my question is, what kind of advice are you giving to the US government, and what kind of advice would you give to us folks in Canada with respect to infrastructure investments? I mean, if I go downtown here in Halifax, they're building Arctic patrol vessels, but the infrastructure that's required in the Arctic is substantial. And so what kind of advice, are you having serious discussions with the US government, and what would you advise to us in Canada?
I mean, we're starting to have some of those discussions in the US. The Coast Guard is busy building substantial icebreaker capacity in the US, which has drifted down in recent years. And there is no doubt that icebreakers will continue to be needed for some time. And there are important strategic motivations for maintaining that kind of capacity. So it does seem to me that the Arctic could become a very active focus for the kinds of conflicts that are being expressed in other parts of the world now, that we could start to see that in the Arctic, and that the Russians outstrip all of us at the moment in terms of their ability to deploy in that area.
Exactly. And speaking of the Russians and the impact on the oil availability and cost, Pascal asks whether or not the decrease in oil availability was integrated in the projections on the behavior of the shipping industry. So,
what we do is we just the way the algorithm works is that it calculates whether it's possible to for a ship to go on a particular route, and we calculate the least cost route each day, and we update the ice every day. So as the ice moves, the route shifts, and we calculate a full least cost route starting on every day of the year. So that does not presuppose how the ship is powered. So what's presupposed are the different SSP scenarios, and those signals are honestly so much larger than what you get from the ships themselves that they're really definitive in that way.
Interesting. You had mentioned to Francis and I, and we're so glad you were able to squeeze us in, that you're actually heading off to Greenland tomorrow.
Yes.
To conduct some research there. I mean, we have a few minutes. So I just wondered if you'd share the nature of the research and the activities you're planning in Greenland, and how long you're going to be there.
Sure. We're just going to be there for a few weeks, but the students will be there for much longer. This is a collaboration between Brown University and the University of Maine, both their Climate Change Institute and also the Maine Law School, that have been, an integral part of this work as well. And so we will be, it's actually part of an NSF NRT, a research training grant. So we're taking students to Greenland. They'll be participating in different types of field work with different scientists associated with things like glacial melt and water quality, fast ice breakup, and there'll be a teaching component with that, and then we'll also be in Nuuk, the capital of Greenland, to have discussions there. One of the things that's very interesting to us is this process whereby Greenland is seeking to its partial or full independence from Denmark. At the moment, they have home rule, but they want to extend that. The issue with that is that it's happening in the context of climate change, and also that they need to finance that. And there are many pathways associated with mining, hydrocarbon exploitation, fisheries, tourism, and the like. And so thinking about what those possible pathways are for Greenland and what the environmental ramifications will be of that is part of what we're kind of initiating now with that government.
Wow, that's fascinating. And what a great opportunity for the students to spend time.
We're sending not just natural science students, but we're also sending law students into the field. And one of the great things that they can do and that they're learning to do is fieldwork compliance. And this is something, we all of us who do field work, we need the lawyers to ensure that we're compliant with environmental regulations where we're working. And so these law students are learning how to do that. And that, I think, is really valuable, and it doesn't happen enough.
Actually, it's kind of related to our public talk tomorrow, which is essentially the science working with Indigenous communities. And you talk about the compliance, but what about, is there a certain strategy or appreciation, engagement with the communities in Greenland and the Indigenous people that you consider in the work that you're doing collaboratively and also with students?
Yeah, absolutely. Well, I mean, 96% of Greenland are Indigenous people, and so a large part of that compliance is associated with certainly issues around artifacts and sacred places and those kinds of things, but also in teaching students kind of the values of respect and acknowledgement, So the one of the things with Greenland is that there's a great deal of clarity about that, which makes it a really good teaching environment, I think, for the students. A lot of the work that I've done with the Inupiat people in Alaska and with Yorta Yorta people in Australia, it's very, very complicated, and you have issues of kind of overlapping governance and stewardship and histories, and grief and anger, and all of those things are kind of tied up in those processes that I hesitate to put a student into that as their first experience. In Greenland, working with those communities, we receive from them a lot of clarity about what's expected of us in that context, that we can adhere to very easily, but that we can also then start to help the students understand, how that kind of respectful engagement can occur.
And also, and really this is the topic of the talk tomorrow, is the bridging of the knowledge systems between Indigenous knowledge and our traditional science knowledge. So, which is extremely important. And yeah.
Absolutely. Yeah. I wish if I wasn't going to be on a plane to Greenland, I would be happily listening to that.
Anyways, I'm going to close with a great deal of thanks. As we heard, I just took a few notes on the societal dimensions of your talk, Amanda: shipping, navigation, sovereignty, the international law, fishing, resource development, infrastructure investment, environment and economics, just to say a few. And all of these things affect people and affect society. And so this was a remarkable plenary talk, a talk extremely fitting to the Congress theme of science serving society. And once again, I'd really like to thank you. I wish you the best in your travels to Greenland, and all the best. And thank you again, once again. And I'll just remind everybody that before I give the last word to Amanda, is that the next session starts in 30 minutes. And certainly thanks for attending.
Thank you very much. I've really enjoyed this, and it provided me with an opportunity to kind of bring together a lot of things that we've been thinking about in many disparate threads. So it was really enjoyable, and I'm hoping that people got something from what we're working on here.
Perfect. Thanks again.